In this lecture, we will discuss different input-output devices, their interaction with the system, what type of instructions will be involved with these input-output devices, what will be the instruction execution during any input-output data transfer. So we will discuss in detail how many input-output devices can be. So in the design of simple computer, let's suppose we have only one input and one output device which are connected with our system. So transferring data in and out of the accumulator using a program IO mode will be used for this purpose. An actual computer system, however, it consists of several IO devices or different peripherals. So first of all, we will discuss one IO device which is connected to this 16-bit computer. So the transfer of information between the processor and the IO device consists of the following three steps. First, the device will be selected and it will be checked that whether the device is ready or not. We have discussed in the previous lecture that the control unit will be responsible for the handshaking purpose. There is a block in the control unit which will check the readiness of the device. So if we are using IO devices for data transfer purpose, first of all the device will be checked for the readiness, whether it is in the state of data transfer or the system has to wait for its availability. So when the device is ready, the transfer initiation will be taken place, and in the third step the information will be transferred. If it is an output device, then the data will be given to the device, and if it is an input device, the data will be accepted from that device. Whenever data is transferred or received by the input or output device, at last the session will be concluded and the system will perform the next instruction or next op. Now we discuss a general input-output model. The IO structure of a simple computer with one input and one output device is shown in figure. This computer communicates with its peripheral through data input lines, which are responsible for input data, and data output lines, which are responsible for the output data. Also, there are two control lines connected to the control unit. One is the input and the other is the output. The data flip-flop in the control unit is used to coordinate the IO activities. This data flip-flop will be responsible for handshaking purpose. It will check the readiness of the device, the availability of the device, and then acknowledge the system about the availability of that device. So in this figure, the accumulator is connected with the input and output devices. Uh, Accumulator is connected with the output device through data output lines, and also it is connected with the input device through data input lines. The output data will flow through data output lines and the input data will flow through the data input lines. In between accumulator and output device and accumulator and the input device, there is a gate or a buffer. Data from the accumulator will not be transferred or will not be flow through the data output lines whenever the accumulator to data output line signal is activated. Also, data from the input device will not be transferred or will not be delivered to the accumulator when the data input lines to accumulator control signal is high. So when the data input line to accumulator DIL to accumulator signal is high, data from the input device will be transferred or shifted or delivered to the accumulator. So there are different control signals which are generated from the control unit. One is the input control signal and the other is the output control signal. When the input device is used for the input data transfer, this input signal from the control unit will be generated and will be given to the input device. When this input signal is active, the input device will transfer or will transfer its data to the data input lines. And when the output signal from the control unit is active or it is high, the output device will accept data from the data output lines. So these two signals are for the input and output device activation, and accumulator to DOL and DIL to accumulator are used to transfer data from accumulator and to the accumulator. The other two control signals which are connected with the input and output devices are set data flip-flop. These two signals are responsible for the handshaking purpose between control unit and the input and output devices. So we have a total number of 6 control signals that are generated from the control unit for the input output instructions. If there is input instruction, then the control signals which will be used for the input purpose or input instruction will be input signal, uh, DIL to accumulator signal, and set data flip-flop signals. So these three control signals will be responsible for the input instruction. For the execution of output instruction, three other control signals will be generated from the control unit. One is the output signal that will be used to enable the output device. The other is the set data flip-flop, which is used for handshaking purpose. And the other control signal will be accumulator to DOL or accumulator to data output. So the next figure will show the generalization of input-output structure to include multiple IO devices. Uh, in the previous slide, we have discussed only one input and one output device. Now, if we have multiple input-output devices, then what will be the procedure to include or increase these input-output devices? So, to address multiple devices, a device number or device address will be used. This device address can be represented in an 8-bit operand field or of input or output instructions, that is read a word and write a word instructions. So in the figure, it is assumed that only 4 bits are used to represent the device addresses. So how it is done, we will discuss in the figure. So it will be possible to connect 16 input and 16 output devices. How it is done, a 4 to 16 bit decoder attached to device address bits is activated during read or write instruction, which will be used to select one of the 16 input or output devices. So these input and output devices will be selected by the 4 to 16 line decoder. There are 4 input and 16 output of this decoder. So whenever a device is selected, that particular line will be activated or high, which will be connected to the input output devices. So if the input control line is active, the selected input device sends data to the processor. and if the output control line is activated, the selected output device receives data from the. So the figure shows a detailed picture of 16 devices that are connected to the accumulator. The accumulator is connected with these 16 IO devices through data bus. Data from the accumulator or data to the accumulator both can be uh, transferred through this data bus. 16-bit of data can be transferred from this data bus. Whenever accumulator sends data to the output device, so data flow will be in the downward direction, that is towards the device. And if devices wants to transfer data to the accumulator or devices are used as input, so the data path will be direction of the data path will be upward. Data will be flown from the device to the accumulator. So in this case, from the control unit, there will be two control signals for the accumulator. One is accumulator to data, and the second one is data to accumulator. The accumulator to data control signal, whenever the accumulator to data control signal is active or high, data from accumulator will be shifted to the data bus, or data from the accumulator will be given to the devices which will be used as output. Whenever there is a data to accumulator signal which is high, so data from the devices will be taken as input data and it will be given to the accumulator. So there are two control signals which are connected with the control unit and the accumulator. There are also two input and output signals which are given from the input and output line. Whenever there is input line, whenever there is a high or 1 at the input line, the devices will be act as input, and whenever there is a high clock pulse or a 1 at the output line, the devices will be used as output device. All the 16 devices are connected with these input and output lines. So how these 16 devices are selected? For this purpose, we are using 4 to 16 line decoder. There are 16 different outputs of this decoder. Each device is connected with one output of the decoder. Device number 0 is connected with the output of output 0. Device 1 is connected with output 1, and device 2 is connected with output 2, and in the same case all the devices up to 15 are also connected with the output of the decoder. So whenever there is a selection of the device, the instruction register will give a 4-bit data to the 4 to 16 line decoder. Let's suppose there is data from instruction register 4-bit data in the form of 0000. So it means that the system wants to communicate between with the device 0. So if 0000 data is sent from the instruction register to the decoder, the output of the decoder, that is 0 output of the decoder, will be active or it will be high. So a 1 will be generated at the output of output 0. So this one will be given to the device 0. When device 0 is given a 1 from the output of the decoder, so it means that this device will be used for any input or output purpose. So if the device is selected by the decoder, then there will be the input or output selection of that device. So if the input line is given 1, so it means that device 0 will be used as input, and if a 1 is given from the output line, then it means that device 0 will be used as output. So in this case, in this way, all the 16 devices can be selected with the help of 4 to 16 line decoder, and we have the uh, availability of a total 16 multiple input output devices. So decoder is also given a read write enable signal. So the next figure is the generalized IO structure, which is used in practice. Here the device address is carried on the address bus and is decoded by each device. Only that device whose address matches on the address line or address bus will participate in either input or output operation. The data bus is bidirectional and the control bus carries control signals, that is input or output. So this figure is showing a generalized IO structure. We have different devices, up to n devices, which are connected with the CPU and the memory. All the devices are connected with separate buses, that is data bus, address bus and control bus. So the address of the selected device will be put on the address bus, and this address will be given to all the devices. All the devices will decode the address which will be flow on the address bus. The address of the device which will be matched, that particular device will be acting as input or output device. So in this way the selection of device will be done, and CPU will be responsible to generate different control signals related to the input or output instructions. Now we will discuss the device interface, which will be in between different devices and CPU. So the figure is showing the functional detail of a device interface. A device interface is unique to a particular device, since each device is unique with respect to its data representation and read-write operational characteristics. So on the basis of the characteristics of different devices, the device interface can be of a unique type. So this device interface consists of a controller that receives command from the CPU and it responds back to the CPU according to the status of the given device. So device selection is the major part or major component of this device interface, which will be used to select the particular device. The transducer section will convert the data which will be represented in the input or output format. And in the case of an output device, the CPU sends data into the buffer and the transducer converts this binary data into a suitable format for the output. So we are showing a detailed picture of the device interface. The device controller, which is the dotted block, consists of a buffer, status, control and decoder. The decoder section will be responsible for the device selection. Different device addresses will be generated by this decoder. The control section or control block will be responsible to accept different control signals from the CPU, and it will also give command to the device. Whenever there is a control signal from the control unit, it will be transferred from the control block to the device. The device will respond back according to its situation via status block, and the status will be given to the uh, central processing unit or CPU according to the instruction or according to the conditions. So the buffer will be responsible to store data. Data from input device can be accepted, can be received from the input device, and data to the output device will be given through this buffer. So in between device and buffer there is a transducer. which will be used to translate data into its particular format. If data is being transferred to the system via input device, so this transducer will decode or translate that input data in the form of binary. And whenever there is data from the system to the output device, this buffer will this buffer will transmit data to the transducer, and transducer will convert this data into the format that will be used for that output device. So in this way, this device interface will work during different input and output instructions.